In this video, we're going to talk about focus and directrix and how they relate to each other. So when you were first introduced to focus and directrix, I showed you the relationship between them. I mentioned for you to draw a straight line, and let's call it the directrix. And because it's a line, we need to understand the horizontal line. The horizontal lines are written as y equals. After that, I asked you guys to write a point somewhere up here, anywhere, and let's call this the focus. Focus being a point in x comma y. And from there, we did an exploration activity where I asked you to fold the paper where you can have this directrix meet the focus. And what it ended up happening was that it created a bunch of drawn folded lines that created a parabola. And then when it created that parabola, I asked you guys to label this part right here as being the vertex. This is not new. The vertex is that turning point in a parabola. It's also that symmetrical point that crosses through the axis of symmetry. So all of these things still apply from a quadratic formula. What is new is your focus and directrix. So we're going to talk about the relationship that they have with each other, which I mentioned through examples, and I even showed you a video. Pretty much whatever distance any point on the parabola to the focus, whatever distance that is the same distance from the point of the parabola to the directrix, anywhere on the parabola. So even if I have a point over here, whatever distance it is to the focus, it is going to be the same distance to the directrix, anywhere. Even if I have it way up here, whatever distance to the focus, it's going to be the same distance to the directrix. Okay? All right, so an example would be for you to study that relationship is by kind of doing examples that are like puzzles, where they give you one thing or two things, and then you need to find the others. So first I asked you guys, if you had, for example, I forgot to mention what the p-value was. So the p-value was that distance right here from the focus to the vertex, and also from the vertex to the directrix. So that p-value is that distance. Okay, so let's say we have a p-value of 3. And then we have a vertex at 3,5. So that means we have a sketch of a vertex at 3,5. 1, 2, 3, 4, 5. Right here. This is our vertex. So if we have a p-value of 3, that means we're going to have 3 spaces down. 1, 2, 3. And 1, 2, 3. Again, it's just a sketch. So if I then tell you that this parabola opens down, you now realize that if this opens down, it's going to go this way, making the directrix be up here, and the focus be this inside point. So the focus will always be inside the parabola, and the directrix will always be on the opposite of the way it's open. So the parabola will never touch the directrix. So keep in mind that the p-value is the distance right here between the focus to vertex and vertex to directrix. So that was the basics from day 1, just kind of filling in the blanks to predict the other values. Then on day 2, that's when we were now writing equations of quadratic equations given this information. So when we use focus and directrix, our equation in quadratics using the vertex formula, it's now using an a value that it's following the formula for p. So for example, we said that the a value will now be 1/4p. So anytime we are writing equations with focus and directrix, we need to remember that a value. I also mentioned that parabolas can open up, can open down, but then now we can also have parabolas opening sideways. And each one will have a different situation going on in the equation based on the direction that it's going. So for the normal one, the one that you have seen since Algebra 1, it is going to follow the original equation of 1 over 4p x minus h squared plus k. The moment you reflect it down, that a value has now become negative. So it's going to be negative 1 over 4p x minus h squared plus k. So then when we have it sideways, a couple of things happen here. The x and the y's switch places, and also the h and the k's switch places. But also, how can you tell if it's positive or negative? It is based on the direction that it's pointing to. So this parabola is pointing to the left. What is on the left side of a number line? The negatives. So because the negatives are on the left side, we are going to use the negative 1 over 4p. And as I mentioned, the x and y flip. So now we're going to have x equals negative 1 over 4p. Parentheses y, and then the h and the k flip as well. So minus k squared plus h. So this sideways parabola pointing to the left will be this equation right here. On the right side, now we're pointing to the right side. So what's on the right side of the number line? The positives. So now we're going to have a positive a value. And instead of the y, we are writing with the x, starting with the x. Again, it's going sideways. So 1 over 4p, y minus k, squared plus h. So this is the 4 different ways that a parabola can be written using the focus and directrix. On the next video, I'll show you some examples on how to do it.